Time crystals are a newly discovered phase of matter that literally breaks the laws of physics. Just as a normal crystal structure repeats in space, a time crystal repeats in time, and most importantly, it does so infinitely without any further input of energy, like a clock that runs forever without any batteries. When the atoms of most materials are in their ground state, that is their lowest possible energy level, they stop jiggling. Time crystals, on the other hand, oscillate back and forth even in their ground state. They can maintain this motion perpetually without losing energy in the process. How is this even possible? Does this mean we are finally close to perpetual motion machines which are considered to be impossible? Let's look at this bizarre state of matter. My name is Siddharth and you are watching The World of Science. Let's start with the basics. Crystals are a solid form of matter that is formed by the regular repeated pattern of molecules. The arrangement is not only ordered but periodical, showing an inherent symmetry in the crystal structure. All the crystals have translational symmetry, which means that if we apply any symmetry operation on a particular crystal lattice, the crystal structure will be unchanged. To say it in simple terms, rotating a crystal around a certain axis may result in the same configuration, just like we see the symmetry in snowflakes. Thus, normal crystals are formed by repeated patterns across 3 dimensions of space. But what if this periodicity is changed from spatial to temporal? The arrangement we would get is known as the time crystal. They are similar to regular crystals, but the patterns repeat themselves not only across the dimensions of space, but also across time. It was first proposed theoretically by Nobel Prize-winning physicist Frank Wilczek in 2012 as a time-based alternative to regular crystals. He was working on the study of crystals and came up with a thought that why not visualize a crystal that has symmetry in a higher dimension other than the regular 3 dimensions, and in a real scenario, the higher dimension could be the time dimension.
Among symmetries, perhaps the most fundamental of them all is time-translation symmetry.
Time crystals are arrangements of systems that break the time-translational symmetry, the usual rule that a stable object will remain the same throughout time. These crystals have repeated patterns in time even when the laws of system are unchanged, that is, invariant. Any symmetry in nature proposes a particular law to be conserved. For example, space translational symmetry leads to the conservation of linear momentum. Similarly, time translation symmetry implies the conservation of energy, that is, the amount of energy of an isolated system remains the same at each point of time. It is neither created nor destroyed. The basic idea of time-translational symmetry is that a change in time does not affect physical laws, that is, the laws of nature that apply today were the same in the past and will be the same in the future. All matter in normal conditions respects the time symmetry, but time crystals show different behavior with the changing time. They change their configuration and transition between 2 or more patterns depending on what time it is. Let's take a simple hypothetical example. Take a system, say a quantum box consisting of 10 electrons. Each electron comes with 2 spin states, up and down. Now, if we randomly shake the quantum box and open it, we can see some electrons with up spin and some with the down spin. This will happen with the case of normal matter, but when we consider the case of time crystals, the situation could be represented by a special case. After opening the box, we see that all electrons are in up state and the next time all are in down state. And this flip-flop pattern continues periodically, with crystals showing one kind of property at a particular time and different at another. Time crystals are non-equilibrium many-body localized systems. That means systems where the particles get stuck in the state in which they started and can never relax to an equilibrium state. In doing so, these time crystals can defy a concept known as entropy. The second law of thermodynamics describes entropy as how any system grows more disordered over time. They can reject the effects of entropy because of a quantum mechanical principle known as many-body localization. If a force is felt by one atom in the time crystal, it affects only that atom. Therefore, the change is considered localized rather than global, that is, throughout the system. As a result, the system does not become chaotic and allows the repeating oscillations to continue for infinite times. To make a time crystal, you will need some atoms such as ytterbium atoms and introduce an electromagnetic field around it with the blast of a finely tuned laser. The field will cause atoms to be entangled and they might flip from one state to another state, and this flip-flopping can go on after the energy is introduced from the laser. Even after the laser stops, the atoms will keep on oscillating and the cycle continues forever between states without losing energy. They are ever-changing, oscillating, but stable systems. Like all the new phases of matter such as Bose-Einstein condensate, this phase also needs a little bit of simulation. It does not exist naturally but can be generated using the proper science. In 2021, researchers at Google in collaboration with physicists at Stanford and Princeton universities used Google's quantum computer to demonstrate a genuine time crystal. Researchers are calling it a milestone in our understanding of condensed matter physics and non-equilibrium systems. This group used Google's Sycamore quantum computing hardware to program 20 spins using the qubits. Classical computers work on bits, while quantum computers work on the quantum version of bits of information that can take multiple values at once using the principle of superposition. Scientists are hoping that more and better qubits can help in a better understanding of the non-equilibrium dynamics of matter physics. This year in June, a research team succeeded in connecting two time crystals by cooling a quantity of helium-3, an isotope of helium. Helium-3 is special because when cooled to a fraction above absolute zero, that is minus 273 degrees Celsius, the isotope becomes a superfluid, which not many materials can do. In a superfluid, there is zero viscosity, so no kinetic energy is lost through friction, thus allowing motions such as those of the atoms in a time crystal to continue indefinitely. Heisenberg's uncertainty principle implies that when a quantum system is observed and measured, its quantum wave function collapses. Because of their quantum mechanical nature, time crystals can operate at 100% efficiency only when fully isolated from their environment. This requirement limits the amount of time they can be observed until they completely break down as a result of wave function collapse. Despite the limitation, researchers observed this time crystal pairing for a record amount of time, about 1000 seconds, which is nearly 17 minutes, equating to billions of periods of oscillating or spinning motion of the atoms before the time crystal's wave function decayed. Indeed, a huge achievement. Time crystals are a new big thing in physics because they can help make quantum computers more vigorous and powerful. Time crystals can be used as memory devices in quantum computers. How much these time crystals can revolutionize the area of physics, only time will tell. But this surely has been one of the most interesting discoveries in science in recent decades, and it is one more example of how different fields of science are now converging to unravel the hidden mysteries of the universe. So what are your thoughts on time crystals? Let us know in the comments. In the next videos, we'll explain concepts like many-body localization and how quantum computers actually work. Do follow us on Instagram for daily quality content that'll make you fall in love with science. Make sure you subscribe to the World of Science. Until next time, stay scientific.